Hello, pre-algebra. Here's Mr. Lawrence with your review for the test. Come on, guys. I know you can do this. Let's start real simple. Let's start with a simple problem like this. 2x plus 5y, excuse me, just plus 5, and we're going to make that equal 11. All right. There's not a single one of you that doesn't know how to solve this. Let's do it really quick together. We're going to get x alone, right? What's keeping the x from being alone? The 2 and the 5. The 2 is attached by multiplication, the 5 attached by addition. So to undo it, I will listen to Saddam. To get the x alone, that is, I will listen to Saddam. I will undo the subtraction and addition before I undo the division and multiplication. So I'll undo the addition by subtracting. Do it to both sides. Remember the Great Wall. You do it on both sides of the wall, not twice on the same side. And when I do that, I'll end up with the equation 2x will equal 6. To get rid of the 2, it's attached by multiplication. I'll divide by 2 on both sides, and I will end up with x equaling 3. All right, simple enough. You're going, why are we doing this one, Mr. Lawrence? Trust me. Trust me. Let's do another problem like this. Let's do 7 minus 3x, and let's make that equal, oh, I'm not in right mode. 10. Okay, this is almost the same thing as the other problem. We're going to get x alone, right? And we're going to get rid of the 7 and get rid of the negative 3. Which one will I get rid of first? Well, Marissa Hecker, remember to listen to Saddam. We have to get rid of the subtraction and addition first. It's not actually that we have to. You can get rid of the multiplication first, but you're probably going to make some mistakes. Trust me, it's easier to get rid of the subtraction first. Okay, or in this case, the addition. How am I going to get rid of this 7? Well, Omar's thinking he should add 7 here, but Omar also knows that 7 plus 7 is 14. Curvin would tell him, we don't want 14 there. We want 0. We want them to cancel out. So I'll bet Megan could tell me that I'm going to go ahead and subtract 7. You know, if I were Mr. Underhill, I might have put a plus sign in front of that 7 to make sure I didn't make a silly mistake. All right, Devin Payne will tell me that I have to subtract 7 from the left-hand side. I also have to subtract 7 from the right-hand side. All right, so the left-hand side will become negative 3x, and 10 minus 7 will be 3. All right. Is the x alone? No. It's attached by, x is not alone because there's a negative 3 attached to it. It's attached by multiplication. Now, Nick Miller, please be careful here. And Giovanni, you be careful too. Oops, I just made a silly mistake. Sometimes you guys like to lose that negative right here. That negative has to come down with the 3x. He belongs to him. All right, so I'm going to divide both sides by negative 3. And when I do so, I'll get x equal to negative 1. Remember to count your negatives. Okay, why did I do that? Because when you have a problem like this, let's say I'll have 4x minus 2y, and that's going to equal 8. All right, I'm going to make my big old table. I'm going to graph this, but I'm going to make my big old table. Okay, I'm going to pick some values for x. I'll tell you this, the x's, or you notice how all the coefficients are even? I got a 2, a 4, a 2, and an 8. I'm going to stick with even numbers. I'll bet you that if I keep 2, 0, negative 2, things are going to work out really nice for me. Mathematically, I won't have to deal with any decimals. So I'm going to put 2 in. All right, let's put 2 in. So I'm going to get 4 times 2. Dominic would tell you, well, I'm going to put 2 in x's place. And you said that very well in class today, by the way, Dominic. I was proud of you for saying that. Now, some of you look at this and go, I don't know what to do. This is the same problem as this one. They're the same problem. You have a number minus 3x equal to another number. Well, look at this one. You have a number. What number is that? Well, that's 8 minus a 2y and that's equal to another 8. It's the same problem. If you could do the previous one and you understood how to do the previous one, then you can do this one. All right, so let me see here. I'm going to go ahead and, oops, okay, we're good. I'm going to go ahead and solve for y. My first step will be to subtract 8 from both sides. When I do so, I will have negative 2y equal to 0. My next step will be to divide by negative 2 on both sides. Y will equal 0. So my first point is the point 2, 0, and I think I'm going to see if I can infinitely clone just him, because I'm going to need him later. I'm going to take him on down. Okay, now that I've done that, I'm going to go ahead and keep plugging away in my table. And I said I was going to put 0 in for x. This one will be a lot easier. I'm going to have 4 times 0 minus 2y equal to 8. What number is this? Well, that's 0. 0 minus 2y, that's just gone. I have a negative 2y equal to 8. Y is not alone. It's attached by, a negative 2 is attached by multiplication, so I'll divide by a negative 2. Don't forget to divide by a negative here. 8 divided by negative 2. How many times did I say the word negative? Once. That'll be a negative 4. A negative 4. So that means that the point 0, negative 4, is also on my graph. And okay, so I have 2 points. I'm going to go for a third point, and I said my x value was going to be negative 2 this time, right? Negative 2. So I'm going to have 4 times negative 2 minus 2y. That'll equal 8. All right. What number is that? 4 times negative 2. I said the word negative once. That's a negative 8. Minus 2y. That's going to equal 8. All right. Now, that's a negative 8 out front there. I'm going to get rid of it by adding 8 to both sides. When I do so, my new equation becomes negative 2y. Careful, Giovanni, don't lose that negative. Equals 16, right? Okay, now I have to get rid of that negative 2. It's attached to y by multiplication. I'll divide by negative 2. From a negative 2, y is going to equal negative 8. All right, so y is negative 8. And so that means the point, let me do it in a different color here. The point will become negative 2, negative 8. So I have my 3 points. Let me clone him. There we go. Okay, so now I have to plot these 3 points. You can't see them all. There they are. The point 2, 0. Remember, that's an x and that's a y. I'll go 2 in the x direction. 1, 2. 0 in the y direction. There's the point 2, 0. I'm going to bring this guy over here so you can see it. All right, in red, I've got x and y. 0, negative 4. I go 0 in the x direction and then negative 4 in the y direction. 1, 2, 4. There's this second point. I'll bring him over. All right, I need a third point. Oops. X and then y. I go negative 2 in the x direction. 1, 2. And then negative 8 in the y direction, which is all the way down here. I'll bring that over. Whoa! I didn't bring the whole thing. There we go. Okay, now I can draw my line. 1, 2, 3, 4, 1, 2. 1, 2, 3, 4, 1, 2. You heard me counting out the slopes, so I could draw a nice long line, take up the whole thing, and I'll give it arrowheads. All right. So, there you go. That's how you do it. All right, now it's easier when you have a situation like this. Okay, if I want to graph that one, that's a piece of cake. That's in what we call slope y-intercept form, right? In fact, my y-intercept is right here. This is the y-intercept, or the b. I go to the y-axis, and I go down 5. 1, 2, 3, 4, 5. Boom. This is my slope. The rise is 2, the run is 3. So I'll rise 2 and run 3 from there. So I'll go up 1, 2, run 1, 2, 3. Rise 1, 2, run 1, 2, 3. Rise 2, run 1, 2, 3. And there we go. All right. So the line will look something like that. Okay, and I'm starting to run out of time. I promised this wouldn't be a very long video. Okay, remember that only works though when the y is alone. If I have a situation like this, 2y equals 4. Let's go with negative 5x plus 4. I don't know the y-intercept yet. I have to go and get the y alone. So in this case, I'll have to divide by 2, and I'll do it in all three places. So then y will equal negative 5 over 2x plus 2. Notice I didn't turn that into 2.5 or 2.5 or anything like that, because to do that would make it more difficult to graph. All right, so this is the graphing part of it. I'll put that in red, and now I'll plot my point. There's my y-intercept at positive 2. Go to the y-axis, positive 2. My slope is negative 5 over 2. I can either go down 1, 2, 3, 4, 5 and write 2. Or from the original point, the y-intercept, I can go up 1, 2, 3, 4, 5 and then left 2. And notice this third point I did here and the second point I did there, they are on the same line. It doesn't matter which one is negative. What does matter is that they're both not negative. All right, there you go. That's graphing in a nutshell. All right, so I think that's where I'm going to stop the video now, is practice for recording. Mr. Lawrence signing off. I do apologize. It was 12 minutes instead of 10, but I think you can spare me the 2 extra minutes. All right, good night, everybody. Good luck tomorrow.